let's get the show started. Hello, everyone. Thank you all for joining. Welcome to InRhythm Lightning Talks. I'm your host, Parag Katkar. I'm the head of consulting practices at InRhythm. InRhythm is a modern product and technology consulting firm, and we have a lot of exciting lightning talks lined up for you. And our lightning talks are hosted every Thursday at 5:15 p.m. Eastern Time. And each week, one of our practice area consultants shares their knowledge on the evolving technology trends in the industry, which will help you keep learning and growing in your career. So this week, Bhavan Kuchibhotla, who is a lead software engineer with us, is going to give us an overview of the performance improvements in Next.js 13. As a lot of you know, Next.js is an open source framework for React that helps developers to create scalable websites. And we see that the popularity of Next.js is growing across the enterprises. So I'm really curious to know about the performance improvements in Next.js 13. So without further ado, let's get it started, Bhavan.
Yeah, hi all. Hello everyone. So let's get started. So let me quickly share my screen. Let's talk about what we're going to talk about first. So this is the agenda for this talk. We'll talk about some common problems that we face as front-end engineers in single-page applications. Then we'll talk about some generic solutions for these problems. Then we'll jump into how Next.js is solving some of those problems. Then we'll open up for question and answers. Staying true to the nature of the lightning talk, we won't see a lot of coding demos and snippets or live coding. We'll majorly talk and discuss in the available time. So, some common problems we regularly see in single page applications. So let's go to the first. I mean, a lot of this stuff would be familiar to most of you and absolutely not familiar to some of you. So let's talk in that sequence. So the simplest problem we generally see, the common problem we see a lot of times is application size. And what is application size and why should we care? So traditionally, each page requires each page requires one HTML file, one CSS file styling, and a JavaScript file for interactivity. All these files are loaded over the internet to render the content onto the browser. So all these general boilerplates that we have for React is something like create React app or any other boilerplate that we have. They bundle all of our app into one or very few JavaScript files and one HTML file and a couple of CSS files. And those are generally served over the internet when somebody loads our page. So, I mean, even if when you set up your own without using these boilerplates, even if you set it up yourself, generally you go when you talk about single page applications, we generally build it this way. So, and a lot of very common use cases where we see some problems with this is unnecessarily wasting network bandwidth of the user. Of course, we should not be doing it. Again, large bundle sizes can delay the rendering of your page. I have seen some applications where the build sizes have gone up to 40-45 MB, which is really bad. That has happened sometimes. And this can affect in multiple ways. One of them is higher bounce rates. People will generally don't wait that long for your page to load, and SEO ranking also will get affected due to the high loading times. So it is generally said, a common understanding is if you're taking more than 2 or 3 seconds to load your page for the user, generally they bounce off. And then another common problem we generally face is rendering performance. And rendering performance is basically any performance that can affect what the user is seeing on the screen. So there is no official definition to it. It can be classified as any performance which affects the rendering of the page, which avoids you to get the page in a smooth way. So generally, this won't directly affect the SEO rankings a lot of times, but it generally affects the user experience. But there are workarounds and solutions that we can actually use to manipulate and behave as if the site is actually performing better than what actually it is performing, which is sometimes which we call perceived performance. So then when we look at the rendering performance specific to fonts and images, majority of the rendering performance is due to the application size, the asset size, and the most common assets are fonts and images. When you look at fonts, heavy custom fonts, if they take time, a lot of time to load, they will result in two things. One of them is layout shifts, majority cases. And what I mean by layout shifts, when you render the page, the first initially there is no font loaded. So the system default font, whatever, based on your operating system, iOS or Windows or Android or whichever operating system it is, there is some default system font available that gets kicked in first. And after the custom font is loaded from Google or from your own custom hosting, wherever it loads from, once that loads in, this form, the existing content in the system fonts get switched to the custom font. So if the character size, character dimensions are different between the system fonts and the custom fonts, definitely there will be, maybe when your custom font is not yet loaded, maybe your content is displayed in, let's say, 4 or 5 lines. But if the dimensions are bigger or wider after the custom font loads, the same 4 line content can suddenly quickly jump into 6 lines or 10 lines. That is, or some another example would be, let's say, image loads. While the image is loading, the browser does not actually take space for it to load later. But when it kicks in and loads the images download over the network, suddenly the page layout changes, which forces a trigger to the re-rendering of the page, repainting of the page, which definitely will directly impact the CLS score. We'll talk about CLS scores later. So we talked about fonts. So heavy fonts are bad generally, if not served the right way. Images, they take a lot of time to load, they're heavy. And once they load, they basically disturb the layout of the page, if not done the right way. And also another very common problem where we face is serving wrong images to the wrong devices. Let's say I have a very high quality image, which is suited for something like a retina screen. I don't need to render that when somebody loads the same page on a mobile. So when that happens, unnecessarily you're wasting the bandwidth, and that will take a lot of time to load. I mean, consider somebody using the same page on a mobile, but let's say on a 3G network or a 2G network. That will definitely impact how long the page will take time to how long the page will take to load. Definitely, you don't need to serve those kind of heavier images for, let's say, mobiles, or let's say I don't even, majority of my users are not really iOS users, and retina displays are high resolution images are definitely needed for retina displays, but the regular laptops may not need that. So that is again a concern there. You may not serve that kind of high resolution to a normal laptop. That is a common performance mistake we do. And we will discuss the common workarounds for this next section. And after this search engine optimization, we'll go to the workarounds, how we can solve these problems generically. So now let's talk about search engine optimization for the people who are not familiar. So what happens is, whenever Google is the undisputed leader in this space, so whenever Google search engine or any other search engine, they scrap all the internet, and they even come to our website and they try to scrap our pages and the content in it. And while scraping, by scraping I mean they basically try to read what's the content on our page. And while they do that, they also look for some key information like titles, descriptions, and some metadata, and a lot of other stuff. They evaluate a lot of stuff, and based on that, they decide a rank for our particular page. So where should it apply? Should it come in the first page or should it come in the top 1, 2, 3 list when somebody searches for something specific related to our page? So that is generally how indexing is done for search results. And that content or metadata we provide, and we are supposed to take care of what, when Google comes to scrape our website, what should it read? The content anyways it will read, but we will generally we should provide extra information for Google to understand what our page actually trying to convey. Google particularly uses more than 130 or some odd number of metrics to decide the page rank of one particular page, and a few of those metrics involve calculating the web vital scores. We'll discuss that later. Later in the slides, we'll discuss that. The web vitals are basically, they decide how usable your website is. So this is all the same content. So the problem with the single page application in this concern is, so by nature, single page applications using any of these boilerplates or custom setup you do for yourself, you basically send HTML or whenever somebody tries to even access part of your website, not really the home page, but some internal page, let's say some article, let's assume some news portal, maybe our website.com/ some article. When they come to that, when they come to this page or the home page or any other page on our website, we generally serve an HTML with no content and JavaScript for interactivity, and that JavaScript will actually deal with the routing of that particular page. By routing, I mean, what is this page? Is this a home page or is it an article page? And if it's an article page, what is the content? Then it goes to backend and brings the content, then renders the content. But while all this happens, Google, any search engine robot will not wait on it. It will just read the HTML content. So initially, our HTML we serve on the first request is generally without content. It does not have any metadata. So that's a big problem. So this was one of the major problems when React, not just React, any single page application started. A lot of people, a lot of libraries solved it different ways. So the SEO scraping robot only cares about the HTML content. It does not really care how beautiful your website is looking, how interactive it is. It will care for some metrics, but generally for data, it will generally depend only on HTML content. So that is the major problem we face for single page applications in terms of SEO. And it's not just the metadata all the times, just like we spoke earlier. So for let's say some pages like the public website, marketing websites, or let's say news portals, generally most of them are public. So for them, SEO matters a lot. But for some CRM like application where you only can see what's the content inside after you log in, that is proprietary information, and you may not need that for an SEO. So single page application works great for web apps. Along with that, SEO also considers, as we spoke earlier, web vitals. Web vitals they have certain weightage, so we don't publicly know exact weightage, but they have certain weightage in while calculating the page rank, at least at Google. And these are generally used to calculate how usable the website is. They calculate load times, they calculate what is the first paint, when is the first paint happening, what is the layout shifts happening, how much is the delay in the inputs, a lot of other stuff. But there are generally three major ones that we'll talk later. Three major ones that Google considers directly impacting the page ranks. We'll come to that later. And a common workarounds for these problems, generic solutions, not really specific to Next. We'll talk about specific Next solutions in the later sections. Common workarounds and common solutions for these problems. Let's discuss that. So application size. The direct silver bullet for application size is code splitting. There is no two ways about it. This logic here is, what is the point of loading all the app when all you know is the user on one page, and you don't know he may go to next, he or she may go to next page or a different page, or they just close down the tab. You don't know that, so there is no point loading all the page, all the application when you don't need it. So here what happens, single page applications, as we already spoke, are generally bundled into one big file, one or two or three, well, like very few big files. That happens in single page applications. So the idea here is to basically split this one big file into smaller chunks, like super small chunks, or in different conventions we do it differently. But the idea here is breaking that big chunk into smaller chunks and load them only when they are required. Or there is another convention where you even break things inside your one page. There is no point of loading a hidden component when it's not even when some action is not really performed. You can load that particular hidden component on demand using dynamic imports. And we'll talk more about this. There are multiple ways to split the code. One of a few of these ways are using suspense, that is straightforward, and using dynamic imports. Instead of importing things, we require components, or we require pages or utilities. We keep them, we require them in the component, in the rendering, or while the page is being rendered, not on the top. We import them dynamically when we need them. Otherwise, there is no point importing them when you're not even really using it. And there are some third parties like Loadable. I mean, there are a lot of third parties. Loadable is one of the most famous third parties which supports code splitting. Internally, it does the same dynamic imports. Loadable has been very popular. I remember using it even before Next was there. I mean, since the time when initially when we needed support for code splitting, this is probably one of the very first few libraries that came in light, and it is battle tested. A lot of lazy websites still use it. I'm one of the consumers of it. And conventions around how you split, where do you split? That's again up to you. Generally, people do it by pages or by components or by features. A lot. I mean, it's all about how granular you want the splitting to be. Like, do you really want to split so much that instead of splitting one file into 30 files, instead of that, if you want to split it into, instead of 30 files, you can put it into 300 files also. Is there a point? That is a decision we have to take. How granular we want the splitting to be. So general conventions are split by page or split by features. And the eventual outcome of this code splitting, as we already spoke, what happens after code split, when we split the code into smaller chunks. So when initial page loads, the skeleton is loaded. The basic structure is loaded, or the first fold is loaded. And rest of the app will asynchronously be being loaded in the background, or when you really go to that page. So that improves our loading time drastically. I remember getting one application from 8 seconds to under 1 second just by code splitting, nothing else. So if it's done correctly, it can do wonders. But if it's done incorrectly, there is always a trade-off between page transitions. There is a chance of getting a white flash screen. But again, that is a trade-off which should be taken for gain performance. Or like it's like minuscule, literally a couple of milliseconds, not even in the hundreds. Sometimes it's even less than maybe 20 milliseconds or something. Like you can't really even perceive it. So, but that is a trade-off that happens when you code split between pages or between components while it's loading. If we understand that file we are loading is like super small, instead of 1 2 MBs, it might be like maybe 10 15 KB. So that's quick to load, but at the same time, there is a delay there, network delay that we'll have to deal with. That is a trade-off we should be willing to take for the overall gain in the performance. So next we talk about rendering performance, common workarounds. So for fonts, there are multiple ways to solve the issue here. So one of the ways is generally the problem with fonts is like they're very heavy to download. So easiest, simplest solution we should be doing is putting them on a CDN or use some fonts like Google Fonts or any other third party which provides fonts on CDN. That is the easiest and simplest improvement we should be doing in terms of load times. And again, fonts are cached, but you should be doing that, caching the fonts, or sometimes even prefetching the fonts. Maybe fetching the fonts as part of the initial required code instead of lazy loading them later. Because once you lazy load, there is a delay in system fonts to the custom font switch. There is a definite delay there. But if you the initial code, so the latency is generally reduced. Also, there is this size adjust CSS rule that is presented in a lot of that is supported in majority of the latest modern browsers, that basically controls the adjustability of the character size vertically and horizontally, whatever the size of the character in that font is. So when the switch happens, there is not a drastic shift. So we can use that rule also. This is one of the things Next also does internally. So that is suggested if we don't only use if we are not using Next and doing it ourselves. These are the generic solutions to that problem. So fonts is basically reducing the latency. Other than that, there is not a lot of things we can do, and switching we can make the switching smoother. And then we look at the images. Images is like pretty. This is a very old problem that people have been solving from last 20 years. So, but the minimum optimization we should be doing as engineers is not serving unoptimized images. And by that, I mean, again, as we already spoke, what is the point of serving a retina image to a lower quality device? There is no point there. So that is the minimum optimization as engineers we should be doing. Also, there is a trade-off between the quality of the image and the resolution of the image and the size of the image. We should play around that between those 3 points and get the right picture that is good enough for our website to load. When if you want the highest resolution and highest quality, you will sacrifice the size of the image, and you'll have to play around that ballpark. Or for some companies, maybe the quality is at most important. They'll have to load that. There is no workaround. But there is a minimum optimization we should be doing is optimizing our image files and serving them to the right devices. In images, we have this source set attribute. It's been there from I think HTML4. A lot of people wish a lot of us we don't still use it, but it is a great way to provide the right images to the right devices. The simplest of it, the simple explanation. So we can just use the source set and specify exact images that we want for exact devices up to this size. I mean, it's more like responsive conditional image rendering. So we all can read about it. It's like pretty standard in the industry. We should be using that. That is the next performance improvement we should be doing. And again, generally the problem comes is like when you render an image, if you don't have the right size, width and height provided to it. So what happens is while the image is loading, the page content is not reserved. A space is not, that dimension is not reserved for that image to load later. So what happens is the content wraps to the top, and once the image loads, suddenly there is a drastic change in the layout that will definitely directly affect the CLS score. Layout shifts is a major problem with images as well as fonts. So we should be, if possible, we should be providing dimensions to the images in the code, images with width and height when available. When they're not available, at least go to the nearest approximation. that should solve the majority of the problems with images in terms of rendering performance. And there is this perceived performance, as we spoke earlier, somewhere I mentioned perceived performance. What is perceived performance? So this is the perceived performance is basically what the user sees in the naked eyes. So what user actually sees and feels is the perceived performance. And there is generally, again, already we spoke about it, an HTML file, a couple of CSS files, couple of JavaScript files. That is what any page is generally. So while the CSS file and the JavaScript files are loading over the network, they are render blocking. So the user generally sees either an empty page or an unstyled page, which is bad. So for that, we have this common practice called critical CSS. It's been there in industry. I don't know, even before a couple of decades. So what we do in critical CSS for the folks who are not familiar. So what we do in critical CSS, so for the first fold, we pick all the CSS available and we put that CSS in line in the HTML. So HTML is the first file that gets loaded, and the inline CSS is not render blocking, while the rest of the page related CSS is downloading in the background. At least this much, at least the first fold is rendered on the screen. So the user will see at least the first fold when the page loads, along with as quick as HTML comes to your browser, it is rendered almost instantly. So a lot of plugins again available here to extract the first fold CSS. You provide the height and width of the device that you plan to support, and it will just pick the class names from that and only extract the CSS related to that and give you a CSS output. And you can use that output and put it in line using some gulp task or some other tasks, some build task. We'll just pull the CSS for that particular first fold and put it in line in the HTML. That is what we generally do in critical CSS. So for the people who are not familiar with this is a great workaround. And this actually, I have with my eyes, I have seen a couple of websites coming from again 7-8 seconds to down to 2 seconds. I've seen just with this because all the CSS is loading in the background. So the user at least see the first page quickly. So again, workarounds for search engine optimization. This is what majority of Next.js will solve for us. So the issue with metadata, how do we solve it? The straightforward answer is single page applications. If you need to have good uh, SEO support, you need to convert it into server side rendered application or a server side generated application. So we'll talk about each of them. So traditionally, single page application, we get the bare bone HTML and JavaScript, and we handle all the routing at the client and render the page content dynamically based on what is the logic that we have in the JavaScript. That is a traditional SPA. The problem here we already discussed. So when the robot comes, it does not wait for you to render the page and then go get the data and based on that decide what is the metadata here. It will just skip and go ahead. So, but what happens in server side rendered applications? The server side applications, so whatever URL you are trying to access, all the content is generated dynamically at the server instead of generating on the client. So when the HTML comes, it comes with the data. And while generating the content, you can specify what is the metadata you want to put or what is the content you want to put. So when the robot comes, it reads a regular HTML file. So it has all the data it needs and it will calculate its required parameters based on that content. That is a straightforward solution. And in server-side rendered applications, we basically build the content first, give that content to the client, and client renders that content. And whatever interaction we need with JavaScript, that will be pushed from the server to the client asynchronously, and eventually, whatever delay we have, that couple of milliseconds, the interaction is also available. But at least on the first paint, you have the content already built for you. When you even look at the source code, The content is generated HTML, and server side generated apps are, they're almost like literally your, instead of 10, it's not a template and dynamic content based pages. If you look at any static site websites, basically ideally what you have is basically each URL has a separate HTML file built. So we can do something similar in React also. A lot of if you're familiar with the framework called Gatsby, it also can do that. Even next supports that. Basically, we built multiple HTML files for each URL, and whenever that URL is requested, we give that HTML, and it will have all the metadata it needs. So SEO problem is can be directly solved with SSR apps and SSG apps. This is the regular workaround, not a workaround, is the only solution in terms of single page application for React. And there is again, as we spoke earlier, we have these web vitals. These web vitals can impact how your page is ranked. These are the major critical three web vitals that generally Google considers. And some of you might know this, some of you might not, but let's go through each of it. The first one is the largest contentful paint, LCP. It's called LCP, yeah. And it is a metric for calculating the loading performance, and ideally suggested by Google. Your initial request and initial content painting on the screen should not be more than 2.5 seconds. If it's under 2.5 seconds, it'll give you a good score. If it's more than that, there is again a threshold for being good, average, and bad. The lower the time, the better the score. Then we got the another vital, which is called first input delay, FID. And this is a metric where Google calculates interactivity, how interactive user page. So when any page is rendered, HTML is downloaded, then some JavaScript is downloaded. The page is painted, but JavaScript comes in and it attaches all the events to the DOM, and things become interactive. So delay between that should not be a lot. So ideally, it should be under 100 milliseconds for a good score from Google. That is recommended by Google, but a lot of websites have that. Some of the websites don't have that. But that is the difference between somebody getting on the first result and the third result. It can be just that. And there is a third critical web vital, cumulative layout shift, CLS, which is the stability metric. So our whatever we discussed till now, the fonts and the images, that directly affects the score. When your font is, instead of 4 lines, it suddenly becomes 6 lines, your page is suddenly, in the next cycle of reprints, suddenly becomes bigger, and there is a lot of change in the layout. And that can even happen for images. Or even simplest example would be you providing a notification on the first page. You don't have a notification, then you load the notification dynamically and show the notification abruptly. That will shift the page. So there are workarounds to handle that. No, this is just one example I'm giving. Let's say something like a notification, some banner on the top. That is the most common use case. And here it is suggested to have a score of 0.1 or less for a good score. And whatever performance improvements we spoke till now, they affect each of these: LCP, FID, and CLS. So fixing our performance can actually increase the vital scores, and vital scores definitely have a weightage on the page ranks. Exactly what is the weightage? That is proprietary. And some of these problems are solved by Next.js by default. Let's look at them. Till now, we discussed the generic solutions. Now let's see what Next.js exactly do to solve it. So let's talk about app size first. So Next directly by default provides you page splitting by pages. And it's been the USP of Next.js from the start, since it's launched a couple of years ago. Since the initial versions, it has code splitting by default, and it uses something called a page router. So it handles all the routing, and by each page it splits the code. So we don't really have to set up a lot of stuff on the back end and setting up how to split the code. That is handled by Next.js directly. So a lot of time of us is saved there. And with the combination of server components and suspense, so Next basically splits the code and load rest of the page as and when necessary. Even the loaders, the suspense is basically it's almost it's almost like giving you a fallback while you're loading, and once it loads, it replaces the fallback with the actual content. So with suspense and server components, we have this available by default in Next.js. So a lot of our time is saved there. A lot of delays will be solved. So a lot of the problems that we discussed till now, they are directly solved by Next.js. We don't have to really do anything or anything of major concern. So now let's talk about rendering performance fonts specific to fonts. So Next.js has this new utility called Next Font, which it introduced in Next 13. Before Next.js 13, it was not there. In Next 13, they introduced this font utility, which serves Google Fonts as part of the first code in reality without any network request. You don't have to add a network, a font related script in the header and everything. You don't have to do any of that. You just have to use this utility and specify which font you want to use from Google. So Google Fonts is directly available, and other third parties are right now not available, but you can still opt for using custom fonts yourself. And next, internally self-host these font files, so they're available 24/7 on a CDN whenever you need. And internally it uses the side adjust CSS rule that we spoke earlier for font switching. So generally, the last time I used Next 13, I built some app recently, and the switching is almost non-noticeable. It's not even noticeable. Like the switch is like quick. It's available. It's made available by Next directly on the first code. So then the next pain point we generally see is the images. And for images also, Next.js provide this image component. They build a custom component images, and it provides a lot of stuff. And some of this content is directly from the docs. So if you're familiar, you can identify that. But let's talk what it provides. The image component provides. It provides size optimization. So it automatically serves correct sized images for correct devices using internally the SRC set we spoke earlier. And it uses modern image formats like WOP, and there is other format. There are other different formats that you can use which are smaller in size and load faster. So Next.js tries to use that and optimize automatically for us. We don't have to do a lot of setup there. And the CLS score, the content shifting score, the layout shifting score. For that, this automatically solve the visual stability by preventing the layout shifts, and it actually makes you mandatorily provide width and height of the image if you're using an image from external sources. It asks you for an approximate size, if not exact size. Whatever size you provide, it will block that much space, so there is no layout shifting happening while the image is loading or after the image loads. So that visual stability Next.js directly provides. And even if you're loading a local image, so it automatically, you don't even have to provide the width and height. It automatically calculates the width and height of that image, and accordingly fix the image, reserve the image size on that page. And also it provides lazy loading of the images by default. So when we talk about lazy loading of images, basically, let's say you have a page that is 5 or 10 pages long. On the screen, you at a time you see one page. When you scroll down, so lazy loading basically simply directly refers to what is the point of rendering the images that are not even in the screen right now. So whenever the user scrolls and that part of the page comes into the view, that time they load the page. That is lazy loading for images. Generally, that is the nomenclature, and that lazy loading is directly supported by Next.js 13. So we don't have to use any third party or any custom setup for that. It uses the native JavaScript native lazy loading capability and uses builds on top of it and provides you lazy loading of images by default. And access asset flexibility. Here we talk about on-demand image resizing. So for this, let's say example, what we already discussed about this. So if you're using a local image, it automatically calculates a size for you. So you don't have to worry about the exactly. Sometimes what happens is you don't know the size of the image. You are loading an image from external source. So if that external source is controlled, it's your backend itself, and if you can control that, ideally it is advised that we along with the image we should be sending dimensions of the images also, so that when we render these images we use those width and heights so that there is no layout shifts, and the rest points we already talk about. And also this provides a lot of extra flexible options for you. Next.js 13 image component specifically, something like, let's say you have a hero image, you want that to be priority number one, and you want to load that no matter first and everything else later. So you can prioritize those by providing a priority prop on these image component. And there are loaders available, there are fallbacks available on the image component by default. So we don't have to do anything special there. And even there is a specific sizes prop you can pass, which actually you can define what are the different dimensions that you want to use for different images for rendering them on different screens. You can set that up if you really want to. So that is how Next.js solves the rendering performance issues. We discussed images, fonts, and we discussed app sizes. So these major problems are solved by Next.js directly, so we don't have to do a lot.
So thank you so much. And as a reminder to everyone, we do these lightning talks at every Thursday at 5:15 p.m. Eastern time. And next week, Nikhil Hiremat, who is an experienced software engineer with us, is going to give us an introductory talk on Kubernetes. And I'm really looking forward to this talk. So please make sure you mark your calendar for next week. Thank you all once again for joining. Have a wonderful evening, and I will see you all next week.